Trigonometry, Chapter 5, Trigonometric Identities, Section 1, Fundamental Identities, Video 1, Review of Pythagorean, Reciprocal, and Quotient Identities. This series is based on content from Pearson's Trigonometry, 12th edition, by Lial, Hornsby, Schneider, and Daniels. In the previous chapter, we explored graphs of trig functions. In this chapter, we studied trigonometric identities. These identities will equip us to simplify trig expressions, solve trig equations, and in the future, simplify calculus problems. In this section, we discuss fundamental identities. In this video, we review identities we've seen in the past, Pythagorean, reciprocal, and quotient identities. Recall from Chapter 1, we derived three categories of identities from the definitions of trig functions. If theta is an angle in standard position, the point x comma y is on the terminal side of theta, and r equals the square root of x squared plus y squared is the distance from the origin to x comma y, then here are the definitions of all six trig functions. Remember that standard position means the initial side is on the positive x-axis. Since x squared plus y squared equals r squared, we can divide both sides of this equation by any of the squared variables to create trig identities. For example, if we divide both sides by r squared, we get cosine squared theta plus sine squared theta equals 1. If we divide both sides by x squared, we get 1 plus tangent squared theta equals secant squared theta. And if we divide both sides by y squared, we get cotangent squared theta plus 1 equals cosecant squared theta. These are our three Pythagorean identities. Memorize them. I'm serious. The sooner you memorize these, the easier your life will be in this course and subsequent courses that involve trigonometry. Also, be familiar with variations of these identities, such as sine squared theta equals 1 minus cosine squared theta. The variations can be formed by subtracting terms to other sides, turning these involved from identities involving addition to identities involving subtraction. We also have our reciprocal identities, which immediately follow from the trig definitions. Memorize these two. Cosecant of theta equals 1 over sine theta, and sine theta equals 1 over cosecant theta. Secant of theta equals 1 over cosine of theta, and cosine of theta equals 1 over secant of theta. Cotangent of theta equals 1 over tangent theta, and tangent theta equals 1 over cotangent theta. Lastly, we have our quotient identities. These are easily verifiable using the XYR trig definitions. Sine of theta over cosine of theta equals tangent of theta. Cosine of theta over sine of theta equals cotangent of theta. To show you how easy it is to verify these, let's pretend that we're verifying the first one by starting with sine of theta over cosine of theta. If we were to replace each of these with their definitions, sine of theta is y over r, cosine of theta is x over r. Algebraically, to divide one fraction by another, you multiply the first fraction by the reciprocal of the second fraction. And again, algebraically, the r's would cancel, leaving y over x, which is the very definition of tangent. So it's not that difficult to verify this one if you know your definitions. Also, the second quotient identity is a direct consequence of the first one because we can simply take both sides of this identity and do the reciprocal. Reciprocal of tangent is cotangent. Reciprocal of sine over cosine is cosine over sine. It is imperative that you memorize all of these. I would argue it's just as imperative that you understand where they come from. The Pythagorean identities coming from the Pythagorean theorem applied to the picture of our angle in standard position. The reciprocal identities coming directly from the definitions of the trig functions, and then I showed you how to derive the quotient identities. Now, if you're having trouble remembering them all, then here's where you should start. Start with cosine squared plus sine squared equals 1. All of the reciprocal identities, and sine over cosine equals tangent. And the reason I recommend starting with these is that the other three are easily derivable from these five. As I already mentioned, you can derive the second quotient identity by reciprocating both sides of the first one. But to derive the other Pythagorean identities from cosine squared plus sine squared equals 1, we can just divide by various trig functions. For example, if we divide both sides of cosine squared theta over cosine squared theta plus sine squared theta equals 1. If we divide both sides of that by cosine squared theta, what happens? Well, the first term becomes 1. The second one is sine squared over cosine squared, which is tangent squared. And the third one is 1 over cosine squared, which is secant squared. Equivalently, we could divide the first Pythagorean identity by sine squared on both sides, and we would get the third Pythagorean identity. So either memorize them all or memorize a few and be able to derive the rest. Now you try. Pause the video and try the following. Which of the following are valid variations of identities? All right, here's your fair warning if you haven't paused the video yet. Solutions in 3, 2, and 1. They are all valid variations of trig identities. In fact, if you were paying close attention, the organization of the 8 identities here is identical to the organization here, minus all the scribbles. Let me get rid of the scribbles. Hello, thank you. Pythagorean on the left, reciprocal in the middle, quotient on the right. Pythagorean on the left, reciprocal in the middle, quotient on the right. So know your identities and their variations.